In today's section, we are going to focus on trapezoids and kites as far as quadrilaterals that we're going to be worrying about in section 6.5. So let's take a look at some of the basic vocabulary that you're going to need in order to be able to really talk about trapezoids. So first of all, when you have a trapezoid, you only have one pair of sides that are parallel. They're still opposite just like they were in a lot of the other ones that we looked at. But one of the things to kind of be careful of in this one is that these are considered to be the bases and these are considered to be the legs. Now, when we talk about trapezoids, when these legs happen to be equal, they are going to be considered to be an isosceles trapezoid. Typically, the word isosceles is something that we use when we talk about triangles. Most people don't realize that things like isosceles and equilateral and those ones are also used with other shapes, just because we use them with triangles the most. So in this kind of a picture, here's our trapezoid, there's our bases. The base angles of an isosceles trapezoid are congruent, according to theorem 615, which means that A and B, these base angles are equal to each other, and these base angles are equal to each other. Now, one other thing about trapezoids as well is that if it's an isosceles trapezoid, the diagonals, which are like BD and AC in the picture that I have, these are going to be congruent. Now, the only other shapes that we've had where we talked about diagonals being congruent are with rectangles. So true for both rectangles, and it's also true for the trapezoids, but only again if they're isosceles. Now, in a kite, if we talk about a kite like this picture right here, the diagonals of a kite are perpendicular. So you'll see 90-degree angles drawn, typically in 2 of them. But if they're drawn in 2, we know that we can assume all 4 of these all have perpendicular diagonals. Okay, let's take a look at an example. They're telling us that this is an isosceles trapezoid, and we know one angle. So if I was to go through and start to solve this, I'm going to have to find angle A when I get done, angle C, and angle D. So this is going to be my little answer box. I'm going to fill these in. Now, what's probably easy for us to see are those 2 right there, are base angles, so they would both be the same, and these 2 would both be the same. Now, in this picture then, if B is 102, that means also that with C, C would also have to be 102 degrees. Now, if I were to look at this, do remember the same thing holds true that we did in the last one. That if I were to take my 2 angles and add them together that are of different colors, they would have to equal 180. These happen to be same side interior angles because of these perpendicular lines. That would be our transversal. So if that's true, if I know my pink one's 108, and actually I don't even need that degree mark there, and then I have my 180 here, if I don't know what this is, I could make this an X because these would both have to be the same thing. So if I subtract from 102 from both sides, so this would mean that both angle A and angle, D, didn't leave my room to write my M for my measure of angle D are both going to have to be 78 degrees. So up here they're going to be 78. Do remember then, looking at this picture, that C and D would be supplements of each other, and A and B are going to be supplements of each other. You also need to remember that thing about the base angles are congruent and isosceles, because that will be trapezoid, because that will be important again. Okay, let's try one kite example, just so you have a kite one to look at. In a kite, I have a picture up here. I can see some angles have been marked. Now they're telling me they want me to find the angle 1, the measure of angle 2, and the measure of angle 3. Now, in a problem like this, probably out of all the angles are up here, the easiest probably to find is angle 1. We know that a kite, oops, let me go back and fix this here. We know that in a kite that the diagonals have to be perpendicular. So if a kite has perpendicular diagonals, then that means the measure of angle 1 has to be 90. Now, I would encourage you, like I'm doing here, to write little notes to yourself about how you solve things. The quadrilateral chapter can be very challenging in geometry because there's lots of little things to remember. So it is kind of important for you to kind of consider that and be aware of that. Now, one of the other things to consider here has to do with this triangle. Okay? In this triangle, we know this is 90, and I want to try and find angle 2. So to find the measure of angle 2, I basically know these three angles have to add up to 180, because that's what it is for a triangle. So in 180, if I were to take away 90 and 32, whatever's left over is going to give me what angle 2 is. So that means that angle 2 is 58 degrees. So this one is 58 degrees. Now, do notice on this, I actually did some kind of little arrangement here so I could kind of pay attention to what this looks like. So now, I know all of this has to do with angle 2. Now my job is to figure out what it is for angle 3. Now in angle 3, if I were to look at triangle ABC, I see that this side, AB, and BC are both congruent. That means that whatever angle 2 is here, this is going to have to be the same thing. So that means that this one over here is going to be 58 degrees. I know that this is going to be 90 on this side, which means to get angle 3, I just take 180, subtract my 90 and my 58, and I'm going to end up with 32. So the measure of angle 3 is 32. Now, let's just go back then and look at our triangles. That means these triangles back to back are identical. That also means these two are as well. That's important information to use later on when we have to deal with things about what we know about kites.